Welcome students. Today we will solve second problem on sectioning. Let us start today's lecture. So we are given one object and we are asked to draw its full section front view. Over here one arrowhead is shown to us and that indicates the front side of this object. It means we have to read this object from this side only. This is the side of observer and let us first observe the dimensions of this object. Dimensions moving from left to right of the observer will be the length dimensions of the object. Dimensions moving away from the observer are width dimensions, and dimensions moving in our direction are height dimensions of the object. In this case, we have to draw full section front view. And in order to draw its full section front view, we have to assume the cutting of the object from this center line. And we will cut this object by using one cutting plane that will pass through this center line, and that plane will divide this object into two equal halves because object is symmetric about this center line. Then we will assume that the front half of the object, which is in between observer and cutting plane, is removed. Then whatever we will left with at the back, we will draw orthographic image of the left out portion, and that will be called as full section front view of this object. Now in order to draw its full section front view, first of all we will identify its front view, and after that we will convert that front view into full section front view. So let us first identify its front view. We know when we will look at this object from front, we will see one visible face and we have to represent one hidden face and one hidden hole in the front view. So if I have to construct front view of this object, I have to construct this face as visible face. Then in this face, we have to show this hole as hidden hole. Then we have to show this hidden face in the front view. So let us start with this face first, and let us pick its lower left corner. Let us mark this point on paper, and from that point we will sketch a line of 44 millimeters. Then from this point we have to draw a height of 14 millimeters in order to draw this face. So from this point we have to draw a height of 14 millimeters. Then we have reached to this point, and from this point we have to draw a length of how much? It is equal to 44 minus 14. So this is a length of 30 millimeters. So from this point we will sketch a length of 30 millimeters. And from this point we have to sketch a vertical line which will represent this face. When we will look at this object from front side, we will see this L-shaped face, and this curved part of this face will be flat face from the front, and this is the limiting element of this curved surface. And from this point we have to sketch height of 30 plus this radius, that is 20 millimeters. So if we have to move from this point to that point, which is the limiting element of this curved surface, then we have to travel this vertical distance up to this corner, and that is how much? It is equal to 20 plus 30. It means from this point we will sketch a vertical line of 50 millimeters. Then we have reached to this point, or you can say this point, and from that point we will draw its limiting element, that is this edge, that is the last visible part of this curve, and that has a length of 14 millimeters. So from here we will sketch a length of 14 millimeters. Then we will join these 2 points to get this L-shaped face. Then in the next step we will construct this hidden face, and for that first of all we have to locate that face. And in this face 2 points are visible to us. So let us pick this point and let us locate this point in the front view or the previous face drawn by us. So this face in the object is over here. And if we will move from this point towards this face, then we will reach to this point, or we can say this point is behind this point of first face, and that point is over here. Then from this point we will measure the height of this face. The height of this face is given to us as 6 millimeters. So from this point we will mark a point at 6 millimeters on this edge. And the length of this face is 44 millimeters. Because this recess is given to us, but its depth is not mentioned. So we have to assume that this recess is throughout the length of the object. So that means the length of this face will also be equal to 44 millimeters. So what we will do, from this end also we will measure 6 millimeter as the height of that face and will mark a point. And we will place our scale in line with these 2 points marked by us, and we will draw a dashed medium line. So this is that hidden face. Now after that we will represent this hole. Now for that, first of all we have to locate this hole in the face. So its location is given as 20 millimeters from top because its center is shown as 20 millimeters from this limiting element. So from this edge we will measure 20 millimeters and we will mark a point here. Then again from this corner measure 20 millimeters, mark a point here, and we will sketch a center line. After that we will draw the hole as hidden hole. Diameter of the hole is mentioned to us as 16 millimeters. So from center line we will measure 8 millimeters on both sides. So from center line measure 8 millimeters this side, and from center line measure 8 millimeters on other side. Similarly over here also, from center line measure 8 this side, and from center line measure 8 on other side. Then we will draw 2 dash medium lines from those points. So we have represented hole also in the front view, and we are ready with the front of this object. Now once we identify the front view of the object, now it will be easy for us to convert that view into section view. So in order to get the full section front view of this object, we have to cut this object along this center line. So let us observe, if we will cut this object along its center line, then what we will see after removing front half portion of this object. Now first of all we will see, are there some openings in the object? Yes, there are openings in the object. One is hole and second is a rectangular opening at the bottom. Then we will see, are those openings cut by the cutting plane? Yes, both the openings are cut by the cutting plane. Then what we will do, if openings in the object are cut by the cutting plane, then we will convert the dashed medium lines of those openings represented in the front view into continuous thick lines, because when we will cut this object from this center line, these openings will also be cut by the cutting plane, and when we will remove front half portion of the object, then edges of those openings will be visible to you, which were hidden earlier. So we have converted hidden lines of these openings into continuous thick lines. Now after this we will observe the overall section of the object at this section from where we have cut the object. Now if we will look at this object from front, we will see L section, and if we will cut this object from this section, then overall shape of the section will remain same, means it will still be a L section at this section from where we are cutting this object. So there will be no change in the overall section of the object. Now next step is that we have to place section lines in the area which was in contact with the cutting plane, or we have to represent the cut surface of the object by placing section lines. So you can see we have cut the object along this center line, and this area is cut by the cutting plane, and this area, this portion and this portion is hollow, means this portion and this portion is hollow. So over here and over here we have material. It means this material and this material was in contact with the cutting plane. So in these two areas or in this surface, we have to show section lines. And we know we draw section lines at 45 degrees to the horizontal, and these are continuous thin lines parallel to each other, and these are equidistant lines. And we place these lines in the area cut by the cutting plane. So these section lines shows us the surfaces which are actually cut by the cutting plane. So now we are ready with the full section front of this object. Now in the next part of this lecture, we will draw full section front of this object and its top view on the grid sheet. Welcome students. In the previous part of this lecture, we have discussed about full section front view of this object. Now we will draw its full section front and top view on the grid sheet, and we will draw these two views in first angle of projection. Now over here I have drawn a reference line of 15 centimeter, and I have marked its left end as X, capital X, and right end is marked as capital Y, and I have written VP above the reference line and HP below the reference line because we are considering first quadrant for the drawings, and we have written these in Gothic style. So let us start with its full section front first. So for full section front, we have to first draw this face. So let us start from this corner, and from reference line leave around 1 row gap or 10 millimeter gap, and align your scale with this row and draw a horizontal line of 44 millimeters and measure it carefully from the scale. It should be of 44 millimeters. Then after that we will sketch this height, and this height is 64 millimeters. 14 plus 30 plus 20 millimeters. So from this end we will draw a thick vertical line of 64 millimeters, and we have to measure it carefully from the scale. Then after that we will sketch this length of 14 millimeters. So from that end we will draw a horizontal line of 14 millimeters, measure it carefully from the scale. Then after that we will draw this vertical line of 50 millimeters. So from here we will sketch thick vertical line of 50 millimeters. Then this length is of 30 millimeters. So from this point we will sketch a horizontal line of 30 millimeters. Then after that we will connect these 2 points to get the face. And after that we know we have to represent this face as a visible face in the sectioned view because we are cutting this object along this center line. So this face will be visible to us. Its height is 6 millimeters. So from this end we will measure 6 millimeters and we'll mark a point. Similarly from the other end we will measure 6 millimeters and we'll mark a point. Then we will align our scale with respect to these 2 points carefully, and we will sketch a continuous thick line. After that we will represent this hole. The center of this hole is at 20 millimeters from top. So from top we will mark a point at 20 millimeters. Similarly on other side. After that we will align our scale with respect to these 2 points carefully, so that scale should be horizontal, and we will sketch chain thin line which will represent the center of the hole. And we know we can use 2 ratios for chain thin line, either 10:1 or 6:1, means length of long dash can be 6 or it can be 10, but length of short dash will be 1 millimeters, and gap between these two dashes will be 1 millimeters. So we have drawn a line of 10 millimeters, 1 mm gap, 1 mm short dash, 1 mm gap, again a line of 10 millimeters. So this is a chain thin line used to represent center lines. Now over here the diameter of the hole is 16 millimeters. So what we will do, from center line we will mark 2 points, 8 millimeters on both sides of this center line. Similarly over here also mark a point at 8 millimeters. Then this side mark a point at 8 millimeters from the center line. Then this side at 8 millimeters. Then we will align our scale with respect to those 2 points marked by us, and we will draw a thick line over here, because when you will cut this hole with a cutting plane, this hole will be visible to us. Then similarly at this point we will align our scale and we will sketch second thick line. Now after this, what we will do in this area, and in this area we have to place section lines, and we will follow same method which we have learned in the last class. Means we will align our scale over here in such a way that scale is approximately at 45 degrees, and we will sketch a continuous thin line. We will start from bottom, we will move towards up. Then what we will do, we will make use of these millimeter lines. You can see the length of these millimeter lines is same, so these are ending at same point. So what we will do, we will place our scale in such a way that we have placed these millimeter lines on the previous line drawn by us. Then we will draw the next section line, that is continuous thin line. If we will do this, then we will maintain a gap between the two lines, and the second line will be parallel to the first line. So repeat the same procedure. Again place these millimeter lines on the previous line drawn by us and draw third line. You can see now the gap is same. So repeat this step to draw section lines in the whole area which is cut by the cutting plane. And this step we have to do with patience, and it is very important step. Section lines must be parallel to each other, continuous thin and inclined at 45 degrees to horizontal line, and these are equidistant lines, and we are maintaining distance between these lines by using this method. Means we are placing every time these millimeter lines on the scale on the previous line drawn by us. So with that method we are able to maintain the gap between these lines. Now you can see we have to now move to this part. So if you have a roller scale, then it would be better to draw these section lines. You can roll carefully up to this point so that orientation of the section lines should remain same throughout the view. If you don't have roller scale, then align carefully with the simple scale for this area so that orientation should remain same. Now you can see orientation of the line is the same throughout, and these are continuous thin, parallel to each other, and gap between the two lines is same. So we are ready with the full section front of this object. Now after that we will take projectors in downward direction from the points of this sectioned view in order to draw the top view of this object. So we will get 3 projectors. These projectors must be parallel to each other, continuous thin, and perpendicular to the reference line. Now let us construct its top view. Now this is the front side. Maintain same direction, but now look from top. So we will see 2 visible faces. This curved face will be visible as rectangular face, whose length will be 14 and width will be 40. And we will see this face also, its length will be 30 and its width will be 40. So let us plot this face. And for this curved face, we will see this limiting element, and we will see this corner. So this corner is just behind this corner in the front. So that corner is over here. It means on this projector, after leaving 10 millimeter gap, we will mark a point. And from that point, we can sketch the top of this face, which will be of length 14 millimeters and width 40 millimeters. So from this point, I can sketch a length of 14 millimeters. So from here, sketch a length of 14 millimeters. That will be up to this projector only, because that face is here in the front, and from these 2 points we have taken projectors. Then from this point, draw the width of that face. Width is 40 millimeters. Then from here, draw 14 millimeters, and we will connect these 2 points, and now we are ready with that face. Now let us plot this face. Let us pick this corner. This corner is below this one, and that point is over here. So how much is its length? 30. So from this point, we'll sketch a length of 30 millimeters. And its width is also 40. So from this point, we'll sketch a width of 40. Then we will connect these 2 points, and we will get the top view of this object. Now after that, we will represent this hole, and we know object is symmetric about this center line. So let us first draw its center line. So width is 40, so at 20 millimeters we'll mark a point, and from that point we will draw the center line of the object, that is chain thin line. So over here I am drawing it thick in order to show you in the video, but you will draw it thin. So it is a chain of long and short dashes. We always start with long dash, we end with long dash. Now you see we have represented the center of this hole also. Diameter of this hole is 16. So this hole is in this length only, that is 40 millimeter, means in this face only. So from center line, we will measure 8 millimeters on both sides. 8 this side and 8 other side. And we will sketch dash medium line over here, because we are drawing top view, not the sectioned view. So in the top view, these holes will be hidden to us. So we will draw dash medium line for that hole. So that hole is hidden from top, so we have represented dash medium lines. Now after this, we will sketch this face which is not visible from top. Its width is 24 and its length is 44. So what we will do, from center line, we will measure 12 millimeters on both sides. From center line, measure 12 this side. Similarly, 12 on other side. Same step we should do over here. So from center line, 12 this side, mark a point. From center line, 12 on other side, mark a point. Then we will connect these 2 points, and we will sketch dash medium line in the total length, because the length of that hidden face is same as that of the length of the object. Similarly over here also, we will sketch the dash medium line, and length of each dash is 3 millimeters and gap is 1.5 millimeters. Now you can see we are ready with its top as well. Now in the top view, we have to show the cutting plane, means we have to show the location of the cutting plane in the top. So cutting plane cuts this object from the center line. So we have already drawn the center line. In order to convert this center line to cutting plane line, we will make the last dash and the first long dash thick. And on these 2 dashes, we will add arrowheads. So this will become cutting plane line. So this is a length of 10 millimeters around, and this is a close filled arrowhead of 3:1. So we are ready with full section front view and top view of this object. Now it's time to place dimensions. So let us start with its length dimension. But before that, we should erase the extra projectors which are outside the top view and which are inside the view. Now let us place its length dimension. So 1 millimeter gap, continuous thin line. Over here 1 millimeter gap, continuous thin line. So I have left around 20 millimeters because I have to place two dimensions. So this is the dimension line for its length. Add closed field arrows on both sides. So it has a length of 40. So over here we will show 40 millimeters. Then let us place this length of 14 millimeters, 1 millimeter gap, thin line, then leave around 10 millimeters gap, dimension line, add closed field arrowheads, and over here we'll mention its length as 14. So we have placed all the length dimensions. Let us place width dimensions. So leave 1 millimeter gap, continuous thin line, 1 millimeter gap, continuous thin line, add a dimension line over here, close field arrowheads on both sides. So over here we will represent its width as is 40. After that we will place this dimension which is of 24 millimeters, leave 1 millimeter gap, continuous thin line, 1 millimeter gap, continuous thin line. So over here we will show 24 millimeters in Gothic style. And you can see over here gap is around 15 millimeters, and between this arrowhead and this dimension line gap is same between these two. So we are ready with the width dimensions. Now let us place the height dimensions. So we can show height this side, 1 meter gap, continuous thin line. Then at the top 1 millimeter gap, continuous thin line, and we can show this height as 64. In Gothic style we'll mention 64. Then we have to place this height. It is of 6 millimeters, 1 millimeter gap, continuous thin line, dimension line, add closed field arrowheads. So over here we will place 6. See, gap is again same, 10 millimeters between object line and dimension line, between both dimension lines. Now we have to show the dia of this hole. 1 millimeter gap, continuous thin line, 1 millimeter gap, continuous thin line, add a dimension line, close field arrowheads on both sides. So over here we will mention its dia as 16. Okay, so we have placed these height dimensions. Now we should place this height dimension over here, 1 millimeter gap, continuous thin line, 1 millimeter gap, continuous thin line, add a dimension line, closed field arrowheads on both sides. So we'll say this is how much? It is of 14 millimeters. So we have placed all the dimensions and we are ready with our answer. I hope this answer is clear to you. Thank you very much.